Hi class, let's take a look at example 4. Now, example 4, they want a polynomial and they want a polynomial that represents the area of the square. They're referring to the largest square. And notice that the largest square is actually expressed in regions. So let me actually find the area of each region. And for example, for region A, we technically have a squared that has lengths of x's and x's. So the actual area, it's going to be x squared, and technically units squared as well. Area C, or region C, it's a rectangle that has a length of y and a height of x. So the actual area is equal to xy units squared. Let's take a look at region B. And B, it's going to be a rectangle which is very similar to the higher rectangle, except that this value here is x and this is y. So let me fix this. And this area is equal to, again, xy units squared. We just need one more piece. This would be region D. In region D, it's the larger squared, whose height is y and length is y as well. So the actual area is equal to y squared units squared. Okay, and then for the final answer, this is going to be the area of this square is going to be equal to technically x squared plus xy plus another xy plus another y squared. And they do want it in simplest form. So this will be x squared plus 2xy plus y to the second. And we're talking about units to the second power. And we're just partitioning each of the pieces in that form. Let me just take another look. But we do end up with x and y, so you're going to end up with two of these pieces. So that would be equivalent to these two xy's, and then area D, or region D, will have a y squared. That's actually it for this problem. I am putting the parentheses on the ends because it technically represents a measurement squared once we plug in specific x's. Let's move on to problem 5. And they also want the area, but in this case, it's specifically to the shaded region. I think it's easier if we first get the total area of the square and then subtract the regions. So in this case, total area of the squared, it's equal to, and in this case, we're just looking at the squared in this form, y and y. This will be technically y squared, and also units to the second power. And then I'm going to label this as region A, B, C, and D. So let me just rewrite it as region A through D. And in this case, well, each of these is going to be a squared of x and x. So the area of each region is going to be equal to technically x squared for regions A and D. This is going to be equal to, well, there's 4 regions with the same size, or in this case 4x squared, and it'll be units to the second power. Now let me box in what we found so far, which is the total area of the squared, and then each of the squares that are not shaded. So for the shader region, so area of the shader region, it's going to be equal to the total area minus each of the pieces, and this is equivalent to a y squared minus 4x squared. Or I'll rewrite it as parentheses y squared minus 4x squared, and this will be units to the second power. Let me fix this y. And that's actually it for this one. I am putting units on the final answer just because, well, we're actually evaluating a given measurement. So if we do plug in x's and y's, that's going to give us an actual measurement. That's it for these two problems. I'll put the other ones in a different video.